Logarithmic equations. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. A logarithmic equation is an equation that involves a logarithmic expression in which appears at least one unknown variable. There is no general rule for solving logarithmic equations, so we cannot find the way of solving logarithmic equations, because no one way will deal with all possible cases. We can solve some logarithmic equations by ensuring that both sides of the equation contain logarithms written to the same base. This logarithmic equation has a single logarithm on each side of the equation having the same base. We solve this sort of equation by dropping the log base b from both sides to set x equals y. Let's solve the following equations. We can see that the logarithms on either side of the equation have the same base. So we cancel log base 4 and equate x plus 5 to 7. X equals 2. We must check that the solution is possible because we cannot find the logarithm of a negative number. Replacing x with 2 into the original equation gives the logarithm of a positive number. So x equals 2 is the solution. Look at this equation. We first combine the logarithmic terms on the right to get a single logarithm on either side. So, to solve this equation, we apply the product rule to rewrite the right side as a single logarithm. Now, expand the brackets and drop the logarithms to solve the quadratic equation. We must check our solutions. Replacing x with minus 2 into the original equation gives the logarithms of negative numbers. And when we replace x with 6 into the original equation gives the logarithms of positive numbers. Therefore, x equals 6 is the only solution. Some logarithmic equations have one logarithm on one side of the equation and a constant on the other. In this case, we rewrite the logarithmic equation in exponential form. Pay attention. We rewrite this equation in exponential form and solve for x. Let's see how it works. Look at this equation. We cannot do much in logarithmic form, so we rewrite the equation in exponential form. Replacing x with 16 into the original equation gives the logarithm of a positive number. Therefore, x equals 16 is the solution. This equation is similar to the previous one. The base is what we are looking for. We rewrite the equation in exponential form and solve for x. We must check our solutions. Since the base must be a positive number, x equals 3 is the only solution. In this equation, we apply the quotient rule of logarithms to rewrite the left side as a single logarithm, and then rewrite the equation in exponential form to solve for x. We must check the solution. replacing x with 2 into the original equation gives the logarithm of a positive number. Therefore, x equals 2 is the solution. We know how to find solutions to simple exponential equations where the base numbers are the same or can be made the same. However, it's not always easy to make the base the same. In these situations, we rewrite the exponential equation in logarithm form to bring down the exponent and find the solution. Pay attention. We rewrite this equation in logarithm form. Now we use the change of the base formula. We choose base 10 so that we can use our calculator. We rewrite this equation in logarithm form. Now we use the change of the base formula. We choose base 10 so that we can use our calculator and solve for x. Take common logarithms of both sides. We use the power rule of logarithms to bring down the exponent and multiply out brackets. Collect like terms. Factorize and divide.